What?
Aiden got caught being racist on camera.
Caught.
It's not this.
Caught in 4K. No, it's definitely not 4K.
Hey, are you ready for a riddle and a conundrum? We got problems here. And they're staring us in the face. That's the output for an AC generator. Voltage goes, sine graph, beautiful sine graph. Voltage goes positive, electrons go forwards, current is positive. Voltage goes negative, electrons go backwards, current is negative. Average voltage?
0.
Average current?
0.
Average power?
0.
Because power is current times voltage.
0 times 0.
Average power is 0. Are the lights going?
Yeah.
Yes.
Do we got a problem?
No.
Yes.
Yes, we got a problem. Average.
Nah, but they're going.
Can we, are we getting the right answer? Are we getting the right answer with P equals VI?
Clearly not.
Average voltage is 0 and average current is 0.
Ooh.
But average power is quite obviously not 0.
There's
Do we care about average?
positive, negative.
Sorry?
Do we care about this average, or do we just care about a single moment?
What we would like to be able to do is use our maths on AC circuits. We would like to be able to use V equals IR.
But I can't.
But that's not obvious from that, is it?
I remember this. We did this like a year or two ago.
No.
Yeah?
That's how we got like 240 out the walls or something, isn't it? Like, it needs some powers in it. Some squares or something.
Yeah, some squares.
Yeah.
Oh, what do you remember? Squares is good. Let's square it. Should we square it? Like
What?
Square it.
What is going on now?
0 squared is 0.
Nice.
Yeah, hard.
So, if our, so
I can't have it.
V is V max sin omega t, and we got something that looks like that. Let's square it. And so we're plotting a function which is called V squared is V max squared sin squared omega t.
Yeah.
What's that going to look like?
Funky.
Is that amplitude?
Greater amplitude
Shorter period.
and all positive, because you ever tried squaring a negative number, what do you get?
Positive.
So it's going to be
Oh, those are all
bigger.
That's not
That's
positive.
how I draw my hands.
Nice fingers.
And so
That's how my fingers look.
that value there is V max squared. And so that's probably bigger. Not necessarily. If our V max was like 0.8 volts, you don't get bigger by squaring 0.8. That makes it smaller. That's 0.64. So it's different though. What's next? Well, if we square root it, then we just get back to something wiggly.
Square it again.
Well, we want a number. We want one number that we can use all the time.
12. 12 is
Clarify. Averages. Come on, averages. What are we doing?
V min squared.
What are we doing?
Oh! It's because it's not going negative. Now you can have an average.
We could average it,
Oh.
and it's complicated, right? You gotta, if you want to average something like that, you have to integrate to find the area under that curve, and then divide by the length of the curve to get the average one. But what it turns out that the average is exactly half of V max squared. So if you find the average of a sine squared curve, it comes out as exactly half the max value. That's cool. So that black line is exactly where we're at.
That kind of makes sense.
Tane, what should we do? Square root it, obviously.
How does this explain what happens in your life?
Because
It will. Doesn't matter.
So that was V squared average. So V, should we call it root mean square? Because we're like taking the root of the mean of the square.
I reckon that's
What?
So V RMS, V root mean square. How about that?
Huh?
Isn't it just the voltage?
be there or be squared.
root mean square. This is the root. We're taking the root. We're doing the square root
Yeah.
of the mean. Mean is the average
Ah.
of the square. The root mean square voltage equals. What do you get if you square root a half?
2.
I mean,
1 over root 2.
Yeah.
V max. And so much more commonly we see this written as V max is root 2 times V RMS. Is that right? Should we box it?
wait.
Same
Oh,
for
true.
current. Same for current. Exactly the same. Just put I's in instead of V's. Should say RMS. It's
Oh,
root
wait,
mean square.
no, it's definitely got an extra root on the end.
And
Wait,
so,
no.
and
What
so,
time is it again?
why
We're going
root
to-
mean square? RMS is a three-letter acronym for root. It's telling us what we just did. Mean
Square.
square. It's what we did to get the number, and we like RMS values because we can use RMS values on our calculator with V equals IR, and we get the right answer.
Wait, what?
So when you plug in to the wall and it says 240 volts, that's not the top of the wiggle and the bottom of the wiggle. That's the root mean square value. How big's the wiggle?
Big.
If you plug in 240 volts in New Zealand, how big's the wiggle?
Pretty bloody big.
Calculate. What's a number?
What do you mean wiggle?
240. Oh shit. Did you just say 21.9?
Well, that's 1.4.
339.41.
So 340 volts.
Oh my god.
When we're building our insulation on our appliances, we want to insulate them to take 340 volts. If we insulate them for 240 volts, that insulation is not going to do the job. Like we need to have thick enough plastic on the wires to deal with 340 volts, because that's how high the voltage is going to go. 50, 100 times every second we're going to have that voltage, not 240.
God damn.